Yo, let's start this shit. What's up, Derek? And what's up, PG King? Hope you both had a wonderful weekend. And I've been dreading this return a little bit because I'm still not happy exactly with how the edges gets cleaned up, but I really can't put more time into it right now. And I'm talking specifically about the vertices and the intersection here. It's not that visible. I mean, it's acceptable, but still not a very big fan. But yeah, I can't put more time into that, so we're gonna move on to the normals because that's something I still want to fix before we start the shader here. And at the end of last stream we fixed it sorta. The only problem we have left are normals for, I think it's for points that only get water from one place. So without the distortion, the normals looks very good. We have a nice ish. Guess we could smooth it out a tiny bit more, but whatever. But as soon as we displace these, we get sort of these white lines, and it represents that the normals are pointing straight up pretty much. And that's because when we calculate this normal, we do it doing cross product between this and this, I think, and this and this. The only problem being that we do it before we have offsetted it. I wonder if that's the only thing we need. But then again, yeah, we do it before we offset it. And if we do it after we offset it, we don't have access to this new position. And that's why it sucks. Okay. It's getting back to me. So it's more a question of, should we be doing the offsetting on the CPU as well? Or can we hack it in some way? Does it exist an easy way to calculate the normal here? With or without offsetting it? One quick second here. This one displaces like we have water here, but it's still extremely low. I wonder what happened. Let's see once quick. This one, yeah. Height 71, water 72. Okay, that's quite weird. If that is true, why... If that's true, this one should be higher up. I'm pretty sure. Same with this one, I guess. Did I do some... Did I add some changes here which I didn't revert? Increase water... that still doesn't fix the... Or actually does it? One sec. This one is still way lower than I thought it would be. One sec, did this fix? I still find it extremely weird that that one is so low. Gotta get to the bottom of that. Yo, what's up, Hercules? Hope you had a wonderful weekend. I don't understand this one. Or maybe. One sec. Could it be... Could it be that... where do we have affected points? it could be that we reach more points with the last step of the algorithm than we previously had, or that we fill them up in a better way. So, oh yeah, that's definitely true. But I wonder if that's the cause of this one. Maybe. So I want to check. Let's add one of these as well. Just see how it looks with that one. Looks pretty good. But yes. Okay, now I think we have the correct. Now we have the correct. And now we have the correct heights on all the edges as well. Yeah, it should be correct for this one as well. The problem with this one is that we are just above. Just above. Okay, great. That's one problem less at least. But then again, so now we're back at this normal calculation here. No idea how we want to work with this one. Yeah, that's true. Terrain patch. Yeah, we use this fucking chaos of a method to calculate the normals on the CPU. We check for visible water. And it works. It works for every point that has at least 2 neighbors with water above ground level. But I'm starting to think... because the problem is, if we take... Can I get a good point here somewhere? We can focus on this one, I think. Yeah. This point right here. Like what we could do, what I would want to do, actually, one sec. I still don't fully understand. Oh yeah, we're getting from this one. Yeah, that's true. Let's see. Okay, so this one, it only has one neighbor that has water above ground level, and it's this one. And that is not enough for us to calculate the normal on the CPU, unless we do some... we alter the check or change the check, or just if we do a better check. Not entirely sure what that would be though. We could check for... I guess I would like to check for if it's equal or bigger than 0, because then we can get this point, this point, this point, even though they are not above ground level. But we won't be getting this, this, and this, and this. Because we want to calculate the normal of this one based on this, this, and this point, but not these. Okay, but anyway. Okay, like this. So if we went, when we calculate the normals, if we do it for every neighbor point, or if we utilize every neighbor point that has a water amount that is bigger than 0, like that would be the most straightforward way to do it. But that means that we also need to reset water to 0 the moment we add ground or whatnot. Like if we compare to 0, I'm afraid that, let's just say that we alter the terrain and water over a long period of time, and some of the edges doesn't get reset to 0 water amount. And they will then screw up the normal calculations, if that's the statement we make them depend on. Let me just try, let's just see what happens if terrain patch, visible water A, visible water B. What if we just do, let's try it. So exit this one. Right now we do visible water is equal to, if water is bigger than ground, but what if we change visible water to be equal to 0? If water is bigger than 0, I just want to see if the calculations we use result in a correct normal. Still don't think it does, but one sec. We're gonna do this as well. We can still see these errors here, because currently we're also recalculating the normal in the watershed. I think we're doing it here, normal OS, and that's about it. Still, what the fuck? Yo, what's up, Geralt? Hope you had a wonderful weekend, man. So this normal right here should have been using, so this one should be using this point, and this point. Do we get... Oh, okay. Yeah. Fuck. So yeah, it does. Which means... yeah, it's pretty much just a plane. Or rather, this one has the same height as this one, and this one has the same height as this one, because they are all three below the ground, and this water spreads to them, so it's like it's the same amount that spreads to all of them. So yeah, the normal is correct. We don't take these points into account, but we still don't get the correct normal. For this one we should... yeah, this one is perfect, this one right here. But I mean, this one was perfect previously as well, because we get water from 1 or 2. Such a hard question. I wonder, okay, what I would want to do is, okay, this one only gets water from this one, so we just copy whatever normal we have here, we just copy it and put it here. But depending on when we do it, we might not have recalculated this normal just yet. So it might lead to some problems. Could we fix that in a nice way? Calculate water normal x, y. We could... definitely want to clean this one up eventually. But what we could do is here do I really want to make this one like recursive? Maybe it's okay. So like we could loop through this one, and if we get to point current, point A, point current minus yeah, so here we try to do something. What I would like to do. So maybe instead of doing this, what we do instead, okay, so here we have visible water A. So we know that offsets I has visible water, B does not. So I wonder if we would just want to take that normal instead of doing these calculations. So we could probably do probably let's comment these one out and do normal is equal to, so we have visible water at A, so I want to do calculate water normal. X plus offset A dot X, Y plus offset B dot Y. No. Offset A as well. If this one is true, I guess we want to do offset B and offset B. So yeah, we loop through this one. If we don't get a normal instantiated, we just take the normal from the neighbor with visible water. This one should exit. Yeah, so doing it this way might mean, or will probably mean, that we're calculating the same normal twice, or maybe even more times at certain points, but let's see if it works and worry about performance later. Although I wonder, let's try it. What? Did we actually get a crash? not a big fan of recursive stuff, but I don't see... I think this one should exit some, or maybe... And let's keep that one open. The fuck? How could this lead to... We need to switch this one back. Yeah. Okay. That was pretty rough. Hopefully we won't get a crash this time around. We'll see. Okay, we do. Why? If water is bigger than ground, yes, then it's visible. Calculate, okay. Calculate water normal. Trying to get to the bottom of why we would be getting stuck in a never-ending. Oh, one sec. I'm wondering... There might actually be some logic to how we fill up this mesh, so, or how we fill up the list of nodes we want to visit. So I wonder if maybe so when we fix the mesh here, we do it fluid solver, we do it recalculate fluid mesh data, and we do it from affected points, and we do it find reachable minima, check fluid overflow. We do it, update fluid mesh, affected points. And we do it here. What the fuck, do we do it 2 times? No. Update fluid mesh. Yeah, the one I'm talking about is recalculate fluid mesh data. Where do we do it? We do it here, here, and here. Okay, beautiful. And we do it, you see, we always do it with affected points, and affected points is a list we never sort, we never order it around, or we never change the order of it. So we always just add more points. I wonder though if we're adding it in the correct one. Maybe we can just calculate them. So like when we call recalculate the terrain patch mesh at index, then we get to this function, and we always do it in the order they were added to the affected points list. So we're moving outwards, always getting less and less water. So when we get to this point right here, instead of recalculating the water normal, we might as well, might as well just ask for the normal. Then I guess we would also like to be able to do something like a terrain patch, position OS, position world space. Something like this. Yeah, this one could actually have crashed because we ask for the index is outside of the patch, because we don't check that one, I don't think. No, we don't. Because that's actually why it could have crashed. Yeah, but anyway, so what we want to do is do this, and I want to do the same thing here, but we want to change offset A to offset B, I think. Well, B has visible water, so we take B's normal. Let's try it. No, what the fuck? Yeah, that still doesn't seem to be it. Is this even worse? Why? 0. Okay, so if we take this point, for instance, this one right here, we try to calculate its normal, so we take this point and this point. None of them are above ground, so we skip it. Then we take this point and this point. None of them are above ground, so we skip it. Then we take this point and this point. A is above ground, this one is not, so we just take the normal of this one. That's what I thought would happen. Then we get to this one and this one. Now we have B, so we take the normal of this one. Then we take this one and this one. None. What the fuck? Why doesn't this work? Am I... Derek, even though the normal's not fixed, it's so cool to watch the water update. Yeah, I agree. I agree. I think it's gonna look real good later on with some water visuals. So the only reason we're getting this normal here, it has to be that this normal hasn't updated yet. But how is that? This one works, this one does not. Is it because we're still... No, we're not doing anything here anymore. The only reason for this is everything. Or does this one look weird as well? Yeah. Yeah, a little bit worried about these two as well. For some reason. This one. But yeah, the only reason for these to be black in this case would be that this one isn't instantiated. And I don't know, I'm pretty sure it should be. Unless... Derek, hey, did you stop doing music during the streams? Yeah, unfortunately I did. I had some problem with... So I had one source that worked extremely good, so ChillHop. Love to use it for my devlogs and so on. But during one of the live streams, someone did a false copyright claim and actually got the stream shut down. And I don't want to risk it. Sorry to hear that happen to you, man. People suck. Yeah, sometimes people do, actually. But yeah, I think it would just be easier to continue, at least for now, without music in the background, and just let people listen to their own music to my stream, if that makes sense. Now, I'm pretty sure this one should give us a normal that doesn't look like this. So, what's up? This one gives probably the best result with some unfortunate stuff like this, but good to know anyway. This is the biggest problem, and I have no idea why won't the normal get calculated the correct way here. And actually, this one, here we get water from here and here, so this one should have a... Yeah, we're not getting... This one is still too bright, I would say. Yeah, of course it is, because it's getting its normal from here and here. This is a hard problem to solve. Actually, maybe we should just do... If... Yeah, because here we can see that. Okay, so is that the same? One sec. Is that what's happening here as well? I wonder. This normal gets calculated the correct way. This one does not for some reason. Yeah, honestly, we probably just want to do. If we have an outside point, we just grab the diagonal of it. But would that screw up? Probably. Could do. But in this case, for instance, we just grab this one's normals, put it here. But that, like, for this one, that's what we're trying to do. We're not doing it for this one, though. Still doesn't work. Fuck, am I handling the edges the incorrect way? Maybe. Why would this one be lighter, for instance? That makes no... Or maybe it does. Yes. Okay. Because... we're getting it going down, going up. That's a problem, definitely. But then again... Which one is it? This one, right? It's this one. What do we have? 47, 75, 75, 70, 47. For some reason we don't even get a good normal for this one. What a hard problem. Like, the thing is, I guess we could just edge point to end point. Yeah, the worst thing is, like, when it gets to edge points, we want the normal to depend on its visible neighbors, but just how we want them to depend on them. Like, we're doing so once again, right now we're doing a vertex displacement, and we're doing it in the shader, and that one screws it up as well. Like, it's hard to calculate the normal before we do the displacement, because the displacement will actually affect it. Still annoyed that we're not getting the correct normal on this one. No idea why. So if one member is visible, just get the normal from that visible neighbor. Yeah, don't know about this one. Yo, what's up, Spires? Hope you had a wonderful stream. And thank you for the raid, appreciate it. Good morning to you too as well. And thank you, appreciate it. The only reason I see, or the only reason I can think of for this one not getting a good normal in this case is that this one hasn't been calculated yet. But that doesn't make any sense. If we take a look at the fluid solver, and when we add points to affected points, no, actually, yeah, okay. So yeah, it could actually be the case. Oh, fuck, could it? Let's see. No, for this point here, I don't see any scenario where this point gets added to affected points before this one. I just don't see it. This one spreads to this one. So why the hell are we getting a are we getting terrain patch? Are we getting a wrong? Position tangent. Are we getting a wrong tangent? I don't think so. Nah, should be okay. Okay, so what if we... I just want to double check this one. Let's do... Let's just invert the normal, see what kind of value we get then for this point. Okay. normals, they look incredibly good pre-displacement, but as soon as we displace, yeah, get this shit. If we displaced on the CPU, we get edges. Yeah, I mean, if we displace on the CPU, we could mark terrain fluid point. We could add a boolean here is edge, and it's an edge if terrain fluid solver. So here we make it into an edge of pretty much. So n dot set value water fluid spread. But here we also set is edge to true. Here we set it to false. Visible water. Spread. Yeah, so here we set it to is an edge false. But one sec. It's a question of how we want to handle edges as well. Do we only have edges, or yeah, the edges should be the ones under the ground, but that still has a neighbor that is above ground. So yeah, that's true. So we just put it here. Does it work for minima as well? Yeah, we can do the same here. So maybe that's an idea instead. So instead of doing the displacement on the shader, because we don't get enough neighbor data from doing it there, I would say. So instead we just do it here. We mark certain points as edge points, and then we always update the non-edge points first. So when we update the mesh, we take affected points, we split it up in edge points and non-edge points. And for the edge points, we use a little bit of a different update within. So this one. Let's see. Terrain procedural fluid point. What do we have here? We have terrain patch, we have X and Y, we have index, and we have yo, what's up, Cynic? Long time no see indeed. Hope you had a wonderful summer. Yeah, I think we're gonna move. Let's see here. Terrain patch. I think. Cynic worked most of the summer but was chill. Oh, nice, nice to hear. Um, yeah, my summer was good. Uh, yeah, I'm just thinking what to say about this. Yeah, it was good. It was good. Worked some and then took 3 weeks off, I think. Um, to meet family, travel a little bit. Yeah, it also felt pretty good to take a break from this water solver stuff, even though we were like, I mean, when we came back to it, it was a little bit of a. It took some time to get used to it again, but yeah, it's been going on for quite some time now. I'm just growing a little bit tired of it. Uh, but okay. So this one, I wonder if we want to do this one on the. Yeah, we want to do it. Okay, so we want to do everything on the CPU because if we do, we can communicate between the neighbors and stuff like that. So when it gets to this whole thing here, whatever we do here and here, we're just gonna do this on the CPU and change the position and stuff on the CPU. We're still gonna read this, I think, but yeah. The main thing being that this and this is gonna happen on the CPU instead. And yeah, I think. Soon I'm picking up a car, the first one tomorrow. Oh, nice. Oh, nice. That sounds like a nice surprise. Yeah, because this one, let's see here. This one screws it up, I think. Let's see, will it still work? So if we want to calculate the normal for this one, um, yeah, so we would pretty much do this point, this point, this point, and this point, and this point. We're updating those first, and then it's time for the edge point. So we take this one. But what happens if we move this one, and then we're supposed to calculate this one, and we move? Like, does it affect stuff in which order we do this? If it's hard. So it's gonna be epic. My plan is to leave it outside the local store, and when we get back from shopping, I must say, oh, nice. I love the sound of that one. Pretty sure we want to do this in the, let's see here, what values do we actually care about here? We care about water and ground level, and then we do, yes, but here we also actually changed this one also. Worst case scenario. I'm not a big fan of this, I don't think. Maybe. What do we... If average water height is bigger than priority neighbor values, then we set it to average water amount. Yeah, because I mean, this is also something we could be doing in the fluid simulator, I guess. Okay. Fluid point, get value, set value, set value. I guess this is where I would like to calculate some, so it would be public first of all. Oh yeah, we're working with struct here, so we don't... Fuck, that complicates things even more. Terrain fluid point... Whoa, 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 one sec. Here we added 2 emphasis points. Here we don't do anything. We add it here, never mind. But yeah, would love to be able to set this to an edge point here. But I guess it doesn't really matter when we do it. Or I just want to make sure before I dive into this that these changes will actually be able to help us solve this problem. But they should. Oh, so close. Oh, one more thing. Yeah, every displacement we're doing is gonna come with, like, we're gonna have to displace the, so right now we only displace the vertex position, but we're gonna displace the normal, UV coordinates, a lot of different things. So probably want to do it on the CPU. I wonder if we can do something like this then. Affected points does contain edge points. That's not good. Let's see here. Update stable fluid state. Affected points. We're doing, let's see, what about terrain patch? We're actually reading all the neighbors here already, so might as well read them again. Why not? Let's see. Okay, so if fluid point, if we let fluid point handle a lot of these things, get water point. Get water point, what does it do? It basically just reads the water amount, makes sure that it's above ground. Yes, while we're doing all of this, could we just displace it as well? Change the position. Maybe. It's a hard problem to solve. I'm wondering. Terrain fluid point, get neighbors. Is this something we should just... Should we just instantiate this one in the constructor here? Because we're gonna reuse it a lot. So might as well. I think so. Or we're gonna do this. Oh, is that so? And then I wonder if we can do... maybe we could just take... But I'm a little bit worried about... That should work. Maybe. And then when we call neighbors here, we just do return order by type. If so, neighbors, otherwise. Actually, we want to do the exact same thing, right? We just return neighbors, otherwise we return this one. And then I wonder, I think I want to have one method for calculating the position and one for calculating the normal. And we're gonna do it using the neighbors. Yo, what's up, Fabic? How was your weekend, sir? It was good. It was good. How about yours? Okay, I think we can simplify this quite a lot and then finally add the additional logic we need by utilizing these fluid points. But I want to make sure that we do it in a nice way right now. Calculate water normal. I think I want a function like I guess we could have a calculate normal here. Fabic may had better. I still hope it was okay. How's the water progress going? Slowly forward, I think. We still have a problem with the normals on the edges of the water, but I think I'm pretty sure we have a way forward now, at least. Yeah, so we're pretty much doing these two. The only thing I wonder, so like when we get the neighbors here, we get them -1, or we do a double loop. I wonder if I think we want to get them like this, but let's see. So what we're doing, we're going from x goes from -1 and 1 x goes from -1 and 1, so it's down here, and then we do y as well. So we start with -1 -1, so this one, and then we move, and then we take this one, then this one, then this one, then this one. What I'm getting at is when we loop through this one, when we want to do when we want to calculate the normals, we want to go clockwise around it. Not sure we will get that result with but then again, switching this to be on the doing these calculations on the CPU instead of the GPU. Will it help us in the end? I'm still worried about the fact that, like, calculating this one depends on this one, which means that But then again, Fabric flipped the fucking triangle. So we would flip it around here. Maybe. But the problem with that one is that we would probably need to flip the triangles on the ground as well. Not sure I want to do that. Or let's see here. Let's say that we would be going with flipping the triangles instead. How do we even decide if a triangle should be flipped or not? Is it gonna be decided by So we would start flipping it. We would probably start flipping this one, honestly. And would it fix our normal calculations? Maybe. Like, it might be worth a try, actually. But let's see. Terrain patch. So for quads that are half in water and half outside of water, for those we want to go with this. Not this, but actually, yeah, we want to go with this instead of this. That's about it. We need to, so given a vertex index, we need to figure out the triangle index. Maybe. Just give me 1 sec. Need to AFK real quick. Okay, back. Fabric, you only need to flip north, east, and southwest triangles from spill direction. I don't know. I don't think spill direction. I don't think spill direction has any say in it. What I think it's more about is if we have a triangle where so here, for instance, if we have a triangle where all of the points aren't either above ground or below ground, then we want to flip it if yes, then we want to flip it if the point that is outside of the ground or under the ground is on the diagonal, right? Oh, no. I know. I think I know. Yeah, we want to flip it. We want to flip a triangle only when the diagonals don't match. Or let's see here. If what I'm thinking of is if these ones are, if one is above ground and one is below ground, that's when we want to flip it. Or does that ever happen? I don't think that ever happens here. Or does it? Yeah, it actually happens here. Okay, so like what's the if statement that decides if if we're supposed to flip a quad or not? And I wonder, will it... We basically have the same problem here. This would be fixed with a flip as well. Although I wonder... Like, why? What makes us want to flip this quad as opposed to this quad? Of that I have no idea. I guess the part we want to avoid the diagonal going to the part outside of the water, but that is something. Here we're gonna have diagonal outside of the water, and that's bad. The fuck. I guess Fabic, my question is, why does the water look good at the start of the pond and not the end? It's because we have the same surface height here, while here we have a downwards flow. So it's like when you start so pretty much you don't have any vector height difference here, but you do have a height difference between vertices here, and that's why we get this alignment that looks weird here. And that's also a fact with, if we would go with a swap triangle solution, I'm not entirely sure it would solve it, honestly. I don't really know, because we have a downwards flow here. You can see it on the normals as well. So downward flow here, and that's when we get these jagged edges, unless we do this. And we have a downward flow here as well. Here we don't have a downwards flow. So I'm wondering, we don't really have a... Would be nice to see how a downwards flow would look if the edges are aligned. Fuck it, let's do it real quick. Let's do this. And then we do this and this. Now we should be seeing, we should have, yeah, now we have it the other way around. That's good. And then let's add some water here, I thought. Hmm. Oh yeah, I've done some changes. Yeah, that's true. Because this is probably not the one screwing us over, but rather, yeah. Let's remove that one. Is there anything else I've screwed up here? What have I changed? Fuck, we're not even getting to step 1 of this one. I'll do a terrain fluid solver. Okay, so when we try and add stuff, do we get to this one, question mark? We'll try and do this. I mean, it's always almost like almost like we stop here, like we never get to this one. The fuck. Yeah, I don't get this. What? What have I managed to remove or add for this one to entirely stop working? That makes no sense. Yeah, I added this one here, but then we changed this one, get neighbors. Is it this one that screws us over? Neighbors, we add a new neighbors, then we add to it neighbor terrain patch. Aren't we able to do this here? Let's do... It should be okay. in P get neighbors, terrain data type, height, yeah, whatever. It contains an, it shouldn't make that much of a difference that we have already instantiated it, right? No. Because it's pretty much like, fuck, is that true? Let's see. Stable fluid amount P is equal to terrain fluid point false. Yeah. What the fuck, this doesn't even get called once. Move data. No way we get stuck in move data. What the fuck? And we just instantly finish it. Terraform creation complete, data update, but why? One sec. Yes. Okay, I get it. We can't really do it like this. I think we're getting stuck in a recursive hellhole here. Because when we get neighbors, we create a new one, and on it goes. Yeah, if we could make it work by flipping the quads from clockwise to counterclockwise, we don't need to keep track of neighbors like that, so... Okay, but now we're working with the old one. Right. Yeah, so what would happen if we did terrain patch? We use this one instead of this one, and we use this one instead of this one. So we're just changing the direction of the quad split right now. So if we do water, yeah, we also want to do yeah, it looks fucking great. But now we have a problem. Yeah, it looks good. I don't know about... But now this one looks like shit. This one. But yeah, if we could make... Yeah, we're moving in the wrong direction, but that's okay. Yeah, so splitting quads could... or... it could work. Still, this one doesn't look... We're doing... No idea. Like, do we have anything for the quads that we want to flip? Like, can we? Is it something that is true for this one? But not if it would be located here. It pretty much comes down to we don't want the diagonal one to go. Yeah, we don't want the diagonal one to go from water and no water, or water and but I guess that is true. Like, it's true for this one as well, but we have a pretty good, even though we would be flipping this one, we would still have that issue, the diagonal going from one to another. But if we would flip this one, for instance, we wouldn't have that problem. So if we would flip this one, we would go from water to water if we walk along the diagonal one. This one we wouldn't be able to flip, nor this one. I don't think we want to flip those. How about this one? We wouldn't be able to flip this one, nor this one. So we would still be getting these. This one right here, I think. But maybe it's not. Maybe it's not too bad. Like this one right here. Oops. Because this one wouldn't be fixed by flipping. This one, these two, however, and this one, and these. Not this one, but maybe. It would be so much simpler if we could do this. Yeah, so what do we want to do? We want to do I times resolution plus j times 6. Then we get the index right. Because if 0, 0, 0, or if it were 1, 0, we would be getting that's not entirely true. Or is it? Yeah, then we would be getting I times resolution plus 0 times 6. Let's just try this real quick. Shouldn't be too hard to get to implement and test. So we want to do something here. Calculate water normal. The offsets are still working with the old ones, so we might need to fix this as well. Or we could just go with all of them, not only the connected ones. Then again, triangles. Let's do private void flip quad. Fuck is it? Flip quad. So if we have this point, one sec. This one, for instance. That's a problem as well. Do we? Does this one count as the first one or this one? Because yeah, that's also gonna affect it. And we should be going in. Okay, so if we do, let's try this. Flip quad. Int x, int y. We're gonna change it to let's do public. So current water, current height. And then we take X, and we want to go, I think we want to go 1 1. Check. P water, P height, and water and height. And then we want to flip it if let's see here. We want to do a XOR here, I think. So P water is bigger than P height. Let's just add those for now. N water is bigger than N height. We want to do this if this one is true and this one is false, or this one is false and this one is true. So if this is true and this is true, we don't want to do it. Or if this is false and this is false, we don't want to do it. I'm pretty sure that's what we want to do. So if this is true, we want to flip it, so we need to calculate the index, and that's basically resolution -1. That's very important. Triangle index is equal to, I'm just gonna do it for the water right now, I think. But triangle index is equal to x times resolution -1 plus y. And all of this times 6. And then we do Do we have access to the mesh here, or it's public mesh filter mesh? Okay. Can we do then mesh water mesh dot triangles? I don't know. Let's try it. Oh, one sec. Yes, we don't even call this one right now, so yeah, we're not gonna see any difference, that's for sure. But yeah, we don't call this one, so let's do terrain fluid solver, and then we recalculate fluid mesh data, affected points, recalculate terrain patch mesh at index, recalculate water mesh at index, So what I want to do here is I want to do a flip quad on this one. I wonder if that's enough. Flip quad IJ. Okay, now we call this one. I'm pretty sure we will get a out of bounds here, maybe. I'm not entirely sure this is the correct way to calculate it, but let's try it. No errors at least. I think we should be... Do we even have... Okay, we have no flips whatsoever, right? No flips. No flips, no errors, so that's pretty much worst case scenario, I think. So why don't we have any flips? Is it because ij plus 1 it should be okay. Or we use p water is bigger than p height. This is not equal to n water is bigger than n height. Yeah, what the fuck. Yeah, this one will... This one will always be equal to this one, so we will never enter this one because I forgot to change this one. So we're pretty much reading p water, p height, and then we're reading it again here. What I actually want to do here is patch patch, patch, terrain data, and xwrapped, ywrapped. Okay, something like this. Let's see. Okay. Prepare data. Update stable fluid result. We pretty much failed instantly. Why? Why? Terrain fluid solver. Prepare data we enter. But then we don't do anything else. Affected points add MP while M is not a minima. We should be doing this once at least. Actually, we failed, so somewhere around. Let's see here. Fluid solver token. This one. Like, we never got step 1 finding minimas, right? No, we just did prepare data. So somewhere around here we entered this one. Yeah, maybe. Maybe we can't do this in a thread. Could that be it? Because I think find reachable minima. I wonder if this one fails for some reason. Update fluid mesh. Recalculate fluid mesh data. Yeah, this one fails for some reason. Flip quad. Flip quad. Okay, so if we instead if we instead do update fluid mesh. Yeah, I'm thinking we're having a problem there. Let's do we have flip quads here? Yeah, flip public void flip quads. Let's remove it from here. And then we do update fluid mesh. Let's just add a private void flip quads. List terrain fluid point. Affected points. Something like that, I think. And the most important part is that we don't do flip quads in a thread, but instead recalculate fluid mesh data, update fluid mesh. Maybe we want to do it here. Update fluid mesh. Flip quads, update fluid mesh, update fluid mesh. flip quads. Flip quads, flip quads, flip quads. Something like that, maybe. Okay, it's visible. I don't know if it's flipping them quads, maybe. And it's a little bit... Oh yeah, it takes a lot of time. That's not good. I wonder why, though. But I want to see... Do we have a flip? We don't have any flips, right? No, we don't. Fuck. Oops. Why don't we have any flips? Fuck, I'm not entirely sure. Like, since we can't do this flip, or we can't do this one, we can't do this on a thread, we're gonna have to rework it a bit. Like, if we can make this work, we're gonna have to rework it a bit so that it actually flips, or so that it does it in, that it doesn't take too long to flip it, because in its current state we can't throw it off to some secondary thread. We need to do it on a main thread, which means we're gonna get stutters. But maybe there's a way to flip the quads. Once again, to flip the quads in a way, in such a way that we can thread it, but I don't know. But yeah, prior one is to just get them to flip, because right now we don't flip them at all. So I just want to do, let's do this and this. Let's just always do whatever we do here. And let's see what we get. So every point that is affected by the water solver should flip, I think. You can see here the stutter we have now compared to how it previously was. It's insane. What do we have? Okay, I'm doing something wrong with the flip itself. Hmm. Oops. Like, I'm wondering, can we flip it like this? Accessing the triangles. Are we flipping them somewhere else? Pretty sure we don't. Not entirely sure about this one. Or maybe I am. if we want to get the triangle index, we need to calculate how many iterations we have run. So I times resolution minus 1 plus j, pretty sure. And then we multiply that with 6, because that's an... So it should be okay. It should be correct. X times resolution minus 1 plus y times 6, and it's this one we use, but for some damn reason we're not getting updated. We do know that we're calling flip quad. Pretty sure recalculate mesh data. Terrain fluid solver, flip quad. For every point in affected points, flip the quads. Okay. And recalculate fluid mesh data. Flip quads, update fluid mesh. The fuck. Flip quad. We don't even have this check anymore. Okay, something is wrong here. I just don't know. Index. Y times resolution plus X. Is it doing it like this that's wrong? Or... we do update mesh after the fact, update vertex data. Scotty, thank you so much for the follow, appreciate it. Fuck, why doesn't it flip? Scotty, hey, just finished watching your devlogs. Love the style of the game videos. Will be sticking around. Appreciate it. Appreciate it. Am I gonna have to... We're gonna go crazy here. Do I want to redo this whole thing? And what the fuck? That's insane. We should be able to. I mean, we should be able to flip them like this. For some reason, water mesh. Mesh. Water mesh, and then we have mesh. We do mesh filter, mesh, and then we change part of it. Mesh filter, mesh is equal to source mesh. Copy from. What happens if... So this is what we have. This is what we want to do. It should be working as we're flipping the quads, but could you... Okay, let's do... Fuck it. I'm thinking about doing something like... I want to get this to work, so let's just do this. Flip quad. Let's just update all the fucking quads. Okay, actually we're gonna... Let's leave this one as is, but we do... Public void flip all quads. And then we do, yeah, we do this. IJ. Yes. And then we do. let's just copy this one. Okay, so if it's not true, we do it this way. If it's true, we do it this way. But then again, I want to try it with... I'm gonna do this. I plus 1, j plus 1. Oh, damn it. Like this. So in flip all quads, we're gonna flip all the quads for all the triangles for the full terrain patch. So we're gonna put it in terrain fluid solver, flip quads. Now we're gonna update fluid mesh. In here we're gonna put tp dot something dot terrain patch dot flip all quads. And then we might as well do this. So basically for every terrain patch where we change a water vertex, we're gonna flip all the quads. Which, if this works, we will only... one sec, I forgot to do something. One last thing, I think. Terrain patch. Yeah, we just do this, but what we want to do in the end then is water mesh triangles, or mesh triangles is equal to triangles water. It updates way quicker at least, but I don't think... No, we don't have any flip quads. Fuck. Update fluid mesh. Did I screw up? Yeah. Okay. Let's try this instead. Okay, now we have them flipped. But all of them are flipped. So what we want to do now is we only want to flip the ones we're actually redrawing. So we're gonna, instead of having true here, we're gonna have this double check. And then we want to flip the ground mesh as well. Let's take a look. But now we're actually flipping it on. Okay, we're not flipping it on everything. Let's see. What the fuck? Maybe this will work. But we want to flip. A tiny bit perplexed on what the hell is going on here. Like this one. Probably makes sense. Let's see what happens if we switch the ground as well, not only the water. Although I'm a little bit... Might want to adjust the normal calculations as well, depending on a lot of things. But yeah, so we want to do water mesh. I guess we could just do ground mesh dot mesh dot triangles is equal to triangles water. Pretty good. Pretty damn good. What's up, Cooler SK? Yes, indeed. Yeah, the only problem I have left with this one is this is extremely good. Very nice. But let's see, before I celebrate, we need to make sure that we're able to get the normals as well. So right now we calculate the normals based on only the connected vertices. Which vertices that are connected or not is changes here. So we can see this one, so for this one we're calculating it the wrong way. So we can see this, it's a little bit of a normal artifact here. And I think it's because, let's see. Yeah, we're calculating it as if it was located like this. And doesn't really explain this one though, does it? Or actually, never mind. We're calculating this normal, and we're calculating it as if we had these. So yeah, we do it based on this one, this one, this one, this one, this one. I can't really explain why we're getting this. Let's see here. Yeah, that's not good. I wonder. Yeah, so these artifacts are definitely, we want to get rid of these as well, and then we're good to go. Why the hell is this one calculated like this, however? We're changing. Okay, could it be? I don't know. I would guess that it has to do with this. Yeah, but then again, like, if we keep having this here, we're gonna get an error. And then we have visible water A, visible water B. Fuck. If we switch. Okay, so I think it mostly fixes. I think that's fucking great. But then again, I think it should be okay. So if we have a point with only I'm still not fully okay with whatever's going on here, but whatever. But so if we have a quad with only one neighbor, so this one for instance, when we calculate the normal here, I think we set it to white, but we don't distort it, so, or no, we set it based on these two. Okay, this is pretty good. Although I wonder about, I actually wonder if we would be getting a better result here if we took all neighbors into account, like these as well. Blur it out a little bit, so that would be 0, 1. Let's see here. 0, 1, 1, 1, 1, 0, and then we would go 1, minus 1, 1, minus 1, then we have 0, minus 1, then we have minus 1, minus 1, then we have minus 1, 0, and then we have minus 1, 1. Just want to see if it smooths it out. So if we get a little bit of a smoother normal, when we take 2 extra points into account. Some issues. And maybe it's a little bit better actually. Okay, but this is great. So, although this one comes with a few of its own artifacts, I mean, it's still quite blocky, but I think I'm okay with it. And I think we can add an extra check. So right now we check if this one is outside of water and this one is, if the state of this one and this one is different, then we flip them. But maybe we could check even more things. So maybe we could check, I don't know, Maybe we only want to flip them if if this one and this one is different and none of these has water, or both of them has water. I think we're gonna try some different things. But I would say the normals way easier to calculate with this approach. I don't know about this artifact. I'll sleep on it, because now I have to run. So tomorrow we're gonna... It feels pretty good that we can fix it by this. But tomorrow we're gonna do a lot of cleanup. We're gonna see if we can get these into place pretty easily, and then yeah, I'm pretty sure, like I can say with 90% certainty that we're gonna start doing the water shader this week, but not tomorrow. So yeah. Great progress in the end. Thank you so much for watching, everybody, and have a great rest of the day. Peace.